It's really amazing that the Flat Earth people are still around after all this time and even making a comeback. Let's take a look at this video, Flat Earth in 5 minutes, from Odd TV, and Odd TV says, "Learning is fun." Yeah, too bad you won't do any of that in this video of theirs. This is miseducation, not education, so we'll go through it.
Water, when unmanipulated, is to find its level. So whether you look at a cup of water, a bathtub, a swimming pool, a lake, or the ocean, it's flat.
No, it isn't. It's actually following the curvature of the Earth. You just don't notice it because that curvature is so slight, the radius of the Earth being something like 4,000 miles.
We have 0 authentic pictures of the Earth, and they're all composites.
This is an outright lie. As a matter of fact, for years, Dish Network had a channel called Dish Earth, where they had stuck a camera onto one of their satellites and beamed the image of the Earth, the full Earth, all the way down to its viewers for free. And it lasted for years, for the whole operational life of the camera. During those years, any Dish Network customer could have just tuned into that channel and seen the Earth from the point of view of that satellite and how it looked at the time.
On numerous occasions, NASA admits that we can't go beyond low Earth orbit,
Citation needed.
which is between 99 miles and 1,200 miles away. The interesting thing is that the moon is said to be 238,000 miles away.
And yet we absolutely did go to the moon, so of course these guys are moon hoaxers as well. If you're a flat earthist, you kind of have to be a moon hoaxer. It goes along with the territory.
No matter if you're on the ground, on top of a building, a mountain, a hot air balloon, an airplane, or looking at high-altitude amateur balloon footage, the horizon never fails to rise right to your eyes.
Actually, it's the other way around. It's your eyes going to the horizon. And that's actually how we evolved. Because usually when you're standing around on Earth, the horizon is the level area, unless the horizon is obscured for you, like you're on a hill or something like that. So that actually helps our sense of balance. So that's actually a product of evolution and not anything about the shape of the Earth. And by the way, if you look closely at these horizon lines, you do see a curvature. It's subtle, you have to measure it, but it is there. So, yeah, nice way to not look at your own pictures. Oh look, they do talk about curvature.
Whether you are looking at Toronto's skyline from Niagara-on-the-Lake, 31 miles away, Chicago's skyline from Union Pier, 43 miles away, or even Oahu from Kauai, which is up to 108 miles away from center to center, or 73 miles away from the closest points. You will not see any curvature where it's supposed to be. According to the Pythagorean theorem, which states that the curvature of the Earth is 8 inches per mile squared, Oahu should not be visible whatsoever, but you can see the whole thing.
You have to account for the refraction of light by Earth's atmosphere. It may seem hard to believe it, but if you're looking at the sun set over the horizon, by the time the bottom of the sun touches the horizon, the sun has actually already set. It's just that the light is being bent by the atmosphere, sort of like a magnifying glass. So you're actually still seeing the sun when by all rights it should be below the horizon at that point. This is also how you get a lot of mirages in the desert, like when you see a city on the horizon that isn't there. Depending on things like humidity, you're actually seeing a city, it's just not in that place, it's just the light's being refracted from somewhere else. And notice here, he's looking at Oahu from over the water, so yeah.
In 1887, Albert Michelson and Edward Morley conducted what's known as the Michelson-Morley experiment. This experiment was attempting to prove the speculated motion of the Earth around the Sun.
No, it was attempting to prove the existence of the ether.
And when it failed,
then it proved that the ether doesn't exist.
Albert Einstein was forced to form the theory of relativity to overcome this problem.
No, the theory of relativity was formulated to establish a set of physics around the constant speed of light, which had been established by Maxwell's equations and also confirmed through observational experimentation. Its relation to the Michelson-Morley experiment was the fact that there was no ether, and so the fact is that all motion is relative. If you're in a spaceship and you're passing by a comet, well, is the comet stationary and you're passing by it, or you're stationary and the comet passing by you? Well, Einstein figured out that that's kind of a meaningless concept, Because standing still with relation to what? If there's no ether, then there's no absolute grid of coordinates in the universe that you could be standing still in relation to. And that necessitated the theory of relativity. It had nothing to do with whether the Earth was round or flat.
In fact, anytime mainstream science is faced with undesirable results, they create a workaround.
No, they modify their theory to explain the anomalous results. So we've got this pause to read thing from Edwin Hubble, and actually they do give a citation on that, so that's good. But think about this. You're at a spot in the universe. You look at all sorts of other spots in the universe, in this case galaxies, and they're all moving away from you, and the further away they are from you, the faster they're moving away from you. Okay, so you might say, well, okay, that's the center. But think about what someone in a faraway galaxy would be experiencing. If you plant your flag over there instead of your initial place, then he sees the same thing. He sees the galaxies near him moving away at a certain speed, galaxies further away moving away at a faster speed, and so on. It looks the same no matter where you are in the universe. So, yeah, nice quote mining there.
The sun is claimed to be 93 million miles away, with a radius of over 400,000 miles, but can easily be proven to be much closer and smaller by tracing the crepuscular rays back to its origin in the sky.
These people don't even understand basic perspective. You know, it's kind of like the railroad tracks, you know, on the flat ground, and they're going off in the distance and they converge at the horizon. Well, let's say that there's a city at the horizon. That doesn't mean that the railroad tracks actually get closer and closer together and meet at that point in the city. You go to the city and the railroad tracks are still parallel and they're going on in the distance. Crepuscular rays are parallel. You're just seeing them at this distorted perspective, going back to their point of origin, which is the sun. But what would he expect to see? If the sun were 10 billion miles away, it would look the same way. The crepuscular rays would always go back to the sun because that's their point of origin. It just depends on how skewed you're seeing them from.
If the sun were indeed 93 million miles away, it would simply be impossible to have angled sun rays, as they should all consistently come in straight.
They do come in straight, but you're looking at them from an angle, just like those railroad tracks are parallel.
According to the globular theory, a lunar eclipse occurs when the sun, earth, and moon are in a direct line. But it is on record that since about the 15th century, over 50 eclipses have occurred while both the sun and moon are visible above the horizon.
What does that have to do with anything? I mean, they're always going to be above the horizon somewhere, you know? I mean, okay, this is just plain idiotic.
It's a common misconception that the shadow of the Earth causes moon phases.
No one says that. The moon phases are caused by the light and dark areas of the moon, the lit area that's close to the sun, and then the other is in shadow of the sun. A lunar eclipse is the shadow of the moon, but that's not the phases. So why don't you learn the basics of what you're talking about before you go mouthing off?
The interesting thing about moon phases is that they are always the exact same 8 phases repeated.
They aren't 8 distinct phases. There are transitions from one phase to the other as the moon goes around the Earth relative to the position of the sun. And I mean, what would you expect? I mean, if you're in a dark room and then you turn on one light and the light's way over in the corner of the room and you hold up a white ball, then the half of the ball that's close to the light is going to be lit up. The half that's further away won't be. And then if you just turn around, now all of a sudden the other side of the ball's lit up. Same thing.
But if we were circling around the sun, these 8 phases would inevitably be reversed from the summer to winter seasons.
What? How do you figure that? How does summer and winter suddenly cause the moon to go around the Earth in the other direction? Which is what it would have to be to reverse the phases. Idiot!
I completely understand that the idea of a flattened stationary Earth seems ridiculous in many ways. But that's only because we are taught the false globe model from the very first time that we enter a school classroom. Not to mention the first time we are introduced to the concept of a flat Earth, it's depicted as a highly laughable world where ships, boats, and water would run off of the edge.
Well, why wouldn't they run off of the edge? If, according to you, the horizon is it, then what happens when you see a ship go over the edge? And why does it look the way it does? Why do you see the bottom part of the ship disappear first, and then just the sail, and then at the very end you see the top of the mast, and then it kind of slowly goes away? Why does that happen if the Earth's flat? If the Earth's flat, you should be seeing all the way to the edge, right?
So I do get it, but it's all part of the deception. I've spent 30 years of my life believing that we were on a spinning globe. It wasn't until I unbiasedly and scientifically investigated the flat Earth claims that I started to realize that there is more to this theory than I originally gave it credit for.
Oh, well, in all of your scientificifying of it, did you ever happen to run across a little thing called a Foucault pendulum? What you do is you take a free swinging pendulum, and it works best if you get a nice long rope a big distance from the fulcrum and have a nice heavy weight at the end, set it to swinging. A little later, it's going to be swinging in a different direction. Even if you do things like, stop air currents in the room from happening, things like that. And lots of people have set this up in places all over the world. You could set it up. And the thing about it is, it's going to change direction because of the spinning of the Earth, and it's going to be based on your latitude. If you were to do this at a pole, then you would see it move directions and move around, and it'd be 90 degrees, and then it would keep going, and then 180 degrees. Then it would be swinging back and forth in the original direction that it was. That would be 12 hours later, because the Earth is spun halfway underneath it. If you were right on the equator, it would never move. And if you're at the other pole, it will be moving just in the opposite direction. So you can also use this to determine what latitude you are. I mean, go about it whichever way you want. You can measure it first and then look it up, or look up your latitude and see what it should be and then see if that matches your Foucault pendulum. But yeah, depending on what latitude you are, it's going to take a certain amount of time for it to shift each degree. You can confirm this easily, and it only makes sense on a spherical spinning Earth.
We are told that the Earth spins at 1,040 miles per hour, while the Earth travels around the Sun at 66,000 miles per hour.
And by the way, we know this because of that Einstein guy you mentioned earlier, who predicted particular patterns of gravitational waves that would happen as a result of the Earth spinning and going around the Sun. Guess what? Satellites have measured it. It's there. It's real. And it can only be the case if the Earth is spinning and going around the Sun. That's the only way you can get those gravitational waves.
Meanwhile, the whole solar system is going inside the Milky Way galaxy at a speed of 490,000 miles per hour. And finally, the entire Milky Way galaxy is darting through infinite space at over 1 million miles per hour. Most people believe this, and yet every experiment ever conducted to prove even the simple spin of the Earth has failed.
Oh, don't be an idiot. The Foucault pendulum. Foucault pendulum! Moron! You don't even need the satellites I just mentioned, which are also incredible proof of it. Actually, here's another question. If the Earth isn't spinning, why do communication satellites stay put? Because with a spinning Earth that goes around once every 24 hours, orbital periods decrease the further out you go. So there's an area called the Clark Belt where the orbital period is 24 hours. If you have a satellite there and it's directly over the equator, then as the Earth spins on its axis, the satellite is going around the Earth in precisely the same way. And so from our point of view, the satellite is at a single point and it doesn't move. Actually, it makes kind of this odd little three-dimensional figure eight type of thing for reasons which are too difficult to go into. Orbital mechanics is kind of weird, but the point is, you point your satellite dish at the satellite, and it's there, and at one point you don't have to continually repoint it, because it's staying in that one position. And anyone with a satellite dish can confirm it. That satellite dish gets a little bit out of alignment and you lose the signal to the satellite. So you line it up to the satellite and you get that good signal and you just stay there. Well, if the Earth isn't spinning, what's holding up the satellite? What keeps it from falling straight back down to the earth?
The same thing goes for curvature. It's never been proven.
Your own photographs showed the curvature, you moron!
And the only time we see it is in movies, NASA CGI, or when we're looking through a distorted fisheye lens.
No, it can't be lens distortion because the curvature is the same no matter where in the frame it is. If it were lens distortion, you would have basically none of it in the center of the frame. It would distort in one direction at the top of the frame and completely the opposite direction at the bottom. Do you not even stop to think for 2 seconds about what you're claiming?
With all that said, please continue to research critically and don't be afraid to ask reasonable questions and speak out.
And don't listen to these odd reality morons. Until next time, stay strong and be free.